so here's, let's do, colors. Here's College Way. I told you earlier, College Way is that recording again? REC?
Yeah.
Good, thank you, thank you. College Way is fairly consistent. It's fairly consistent. So when I draw this, essentially, that's what you're driving on College Way. At least from the Mobil station or whatever it is, Texaco, whatever gas station that is, to Portland. It's fairly consistent as far as grade goes. And it's going to rise. Oh, can I bust a little bit of algebra here? It's going to rise 6x for every 100x of run. Is it okay that I put that x in there? Is it okay? Now you put whatever multiplier in there you want. If you want miles, multiply it by 5,280. If you want kilometers, multiply it by 1 because Europeans are smarter than us. Yeah. You know, whatever you need to multiply it by that. But the ratio of 6x to 100x is 6 over 100, which is 6%, and happy. So there's College Way. College Way. Okay, fair enough? So if you took a tape measure, which I want to give you guys after our break, if you took a tape measure and measured this distance and divided it by that distance anywhere on College Way, roughly 6%. Anybody foresee a problem with that? Well, say that again, son. How are you going to tape measure into the road? That's a problem, isn't it? We'll deal with that by the end of the day today, I promise you that. That's the way I brought this bad boy. That's why I brought this bad boy with us. Okay. So anyway, there's College Way. Does anybody want to hazard a drawing as to what Juniper would look like? What would Juniper look like? I don't need crazy accuracy, but just a quick look. Get up here. You want green or red? Green. Green. Here you go. Let's see Juniper. It starts and stops at the same spot. Oh, can you draw right on top of this one? Yeah, I think that'll be start here though. Start here right and end here. But where would the hypotenuse? Where would the road go? Oh, I love it. Ah, yes. That's exactly what Juniper does. Now, may I think? Yes, I think so. I think so. Yes. Yes. Golf clap. Yes. Golf clap. Yes. Quite nice. Quite nice. May I straighten it just a smidge? Yes. You actually drew what probably is... No, what you drew is probably what's actually happening on the road. Roads are very rarely straight lines. They undulate, they follow natural topography. But I'm gonna, just to make it a little more clear, I'm going to straighten out this section, and then I'm going to put a hard angle on that section. That's what's going on. So where College Way has a uniform 6% grade. So roughly for every 100 feet you're traveling horizontally, you're going up 6, over 100, up 6, over. It's like a set of stairs, basically. Juniper is a set of stairs to here, and then it's a steeper set of stairs from here. But do you see how you start and end at the same place? If you start and end at the same place, the grade has to be the same. Here's a misleading potential. Christian, does that make sense? Does that make sense to everybody else? Here's another road that has the same grade as Juniper and College Way. No. If you define grade as rise over run, you have gone 6 something vertically and you've gone that much horizontally. Think about it. These are the triangles we cannot see, Hassani, as you brought before. Think about it. You went that far horizontally. Now, you netted a lot more elevation, but your overall elevation, you only gained that much. You see what I'm getting at? Yeah, you dropped and then came back up, so you negate, basically when you dropped down here, you made up for that right here. And then you picked this up. That's the same grade, friends. So if there was a road in town, and in Bend, I'm surprised there isn't, that did that, it would have the exact same grade of 6%. It would be no different because, oh, say that again, Dad.
I'm sure there is.
Somewhere.
The river would be at the bottom.
Sure, if the road went into the river, came back up again, or at least close to it. So the idea is your overall rise and your overall run, the ratio of that is grade. So yeah, the definition of grade is rise over run, but I'm just going to put a more general definition of average grade. Now it's still rise over run. Yeah, Linda.
So Sean, when you're driving down the road though, like Juniper to me would be maybe a 10% grade, where the College Way would be a 6% grade. And this other one, the red one you just did, would be more like a 50%.
Hold that thought, if you would. I want to come back to that. You're about 45 seconds ahead of me.
Okay.
And it has to do with this idea.
Okay.
You're right there. You're right there. Hold that thought. Your average grade, okay, is going to be your net rise over your net run. And when I say net, I mean figure out where you were at the beginning and figure out where you were at the end and form the difference. Remember that definition? You did this back in algebra class. The change in y, y2 minus y1 over x2 minus x1. You did that back in algebra class, didn't you? You did that back in algebra class. You took your y coordinate, that's in a picture, that might even make it x2, y2, x1, y1. All three of those roads that we drew up there, the red one, the green one, the black one, they all start and stop at x1, y1, and then x2, y2. They couldn't be more different in how they got from one to the other, though. In algebra class, this was the only line that you talked about between those 2 points. Because the whole point of slope was that it was on a line. Average grade does not care how much you go up and go down. It's the average grade. Yes, Linda, this is an extreme case. And many new programs that track elevations will not just track net grade, they'll also track overall grade. So for example, when I do the Mackenzie Pass ride, Sisters is at like 3,200 feet, and D right is at 5,200. So that's 2,000 feet of climbing. I go up and over and end up down at 126. That's about 1,500 feet elevation. Then I come back up to D right. So that's 1,500 to 5,200. So let's call that 3,500. So if you think about it, I go up 2,000 from Sisters, then I drop and I come back up 3,500. So it's roughly 5,500 feet of elevation. That's about a mile of climbing. Do I climb exactly a mile? No, because that road, if you look at it closely, does this. Some programs now will actually calculate every time you go up and then drop in again. So in other words, they'll give you an overall elevation chart. Well, they will count all of this extra plus this here to let you know exactly how much you did go climbing. And I love that because that gives you a nice overall look at how much effort you did. For example, the Black Road College Way, the amount of climbing is much, much less than the Red Road, although their average grades are exactly the same. Is that fair, Linda? That attacks what you said. I'm not doubting you. This looks like, first of all, this grade's negative, isn't it? This part of this road is a negative grade because it's dropping. And this one has a positive grade. Yes. But if you weight it with the negative and the positive, it's going to average out to 6%. That's the point. 6% great. Over the weighted sections of the distance, yes. It's going to average out to a 6% grade. Andrew, go.
I just question, there's really no like a negative grade, it just depends on which way you're going.
It does. If I'm going from here to here though, since I'm dropping, it's a negative grade. Andrew's point is valid. That's why the signs on the roads I don't think indicate a negative or a positive. Depends on which way you're going. Although that sign we opened with, the 6%, it was looking like it was going downhill. But I think a negative 6% would probably freak people out because we all hate math.
Usually when you're looking at the grades, they're always going downhill for the
Well, that's why they want to warn you, because that's when things can go horribly wrong. And usually at the bottom of those hills, what do you have? The runouts. Those things look ridiculously fun until you realize when they're used. They're used when brakes fail. And you think about it, 6%, it's like, what's 6%? Big deal, big deal. 6% is not that much of an angle. What is 6% as an angle? Let's go back to Andrew's question here.